Alrighty, so then we get to lesson 9.2, which talks specifically about soil and how it's the foundation of agriculture. So soil by definition is a system consisting of disintegrated rock, organic matter, water, gases, nutrients, and microorganisms. So soil is derived from rock, meaning that it comes from rock of some sort, but it is shaped by microorganisms. And so most soil is made up of 50% mineral matter, that would be the rock, 5% organic matter, living things, and 45% pore space. And the organic matter can include living and dead microorganisms, decaying material from plants and animals. So if you see here, we see fungi in here, we see some mites, little tiny insects, we see single-celled things, protists, bacteria, a beetle grub, an earthworm. So these are the living organic matter that make up soil. So the composition of the soil is strongly influenced by the character of the ecosystem. So the living things that are there really affect the composition of the soil. And oftentimes soils by themselves are considered ecosystems because they're made up of living and non-living things and many different kinds of species. So soil, as you might guess, is super important for farming, for agriculture. And so when agriculture first started, there was an availability of deep, nutrient-rich soil because it hadn't really been farmed yet. At this point, most of the soil has been farmed at least once, many times over, and so now it's moving away from being fertile, right? It's losing its nutrients, it's losing all of these things. So productive soil is a renewable resource, but we have to be careful because it's renewable, but it is exhaustible. And the reason that we need soil for agriculture is that because plants need soil to provide nutrients for growth. So plants get their nitrogen and their phosphorus, those two limiting reagents, limiting factors. They need the structure. So they need that. This is how plants stand up, right? We have legs. Plants need roots to be able to keep themselves upright. And they also need a medium to hold water and nutrients because plants get everything through absorbing water from their roots. And so they need a soil that can sustain water that has the nutrients in it. So plants also are going to depend on the living organisms in the soil. There's one specific example. Okay, there's not a picture of it. I think there's one. Oh, there's not one in your book. So a lot of plants have this symbiotic relationship with single-celled fungi, and it's called mycorrhizae. And basically what it is that the mycorrhizae, the fungi, live on the roots of the plants, and the fungi are able to provide water and nutrients for the plant because they're able to break down some of the organic molecules in the soil to make them more accessible for the plant. And then the plant does photosynthesis and delivers some of the photosynthesis, some of the carbohydrates to the fungus, able to get what they need. And this fungi that are part of the soil are part of the reason that plants can be so successful in that soil. So we've talked a little bit about soil formation before through the process of succession, and it happens only during primary succession because an event that leaves soil behind would then follow through secondary succession. So what happens is elements of the hydrosphere, the atmosphere, and the biosphere are going to break down a parent material in the lithosphere, so the rock part of the planet. Now, parent material is the base geologic material in a particular location. Basically, it's the rock that is underneath all the soil that's going to form the soil. So this can come from hardened lava or volcanic ash that can be turned into soil. Sediment deposited by glaciers or flowing water, so there may be some sedimentary rock down there. Wind-blown dunes can be the parent material. Also, bedrock is another potential parent material, which is just the solid rock that makes up the Earth's crust. So nothing else on top of it, just the solid rock. And so the parent material is a hard rock, but what happens is that it's broken down into smaller pieces that become the soil through the process of weathering. So there's three kinds of weathering: physical weathering, chemical weathering, and biological weathering. Physical weathering happens when wind, freezing, and thawing happen. So the wind breaks the parent material apart, the rain, as water flows over it, breaks it apart, and then freezing and thawing expand and contract the spaces within the rock, leading it to break apart. Chemical weathering happens as water or gases chemically alter rock. So this could be from acid rain or anything like that, just changes in pH. Biological weathering happens when as you could guess, probably living things, such as lichens. Lichens are the things that are a combination of moss and fungi, and they'll produce acid that will break down the parent material, or tree roots rubbing against the rock can also cause weathering. So further biological activity deposits organic matter in the form of decomposed organisms or waste. So as biological activity continues, more dead things are going to fall on the soil, and they are as waste or dead things, right? So the partially decomposed organic matter. So it'll start to decompose from the materials in the soil, but as it's partially decomposed, it's called humus, and it's very productive for plant life. So it has a high in organic materials, and it's really great for plants to grow. And it's a dark, spongy, crumbly mass of material made up of complex organic compounds. Soils with a lot of humus hold water well, and like we said, they're really productive for plant life. So weathering and accumulating of organic matter are influenced by several factors. So the speed at which weathering occurs is going to be affected by a lot of these things. So climate. Warm, moist climates accelerate most weathering processes because high temperatures and an increase in moisture increase the speed of most biological processes. So it's just going to make things happen faster. That's chemistry. The particles are going to move faster. Organisms will affect it. Plants and decomposers add organic material. So just as decomposers and plants are available, they're going to add more organic material to the soil. Topography, meaning the landscape, hills, valleys, mountains, rivers, all of that stuff. So hills and valleys affect exposure to sunlight, wind, water, and influence soil movement. So if you're on one side of a mountain, you might not experience as much weathering as on the other side or in a valley or things like that, just because wind and water and all of these things affect weathering. So the parent material itself will affect soil formation. Some parent materials weather faster than others, and time is a big one. Soil formation takes forever. It can take centuries, decades, or millennia. So time will really affect how the weathering occurs. And I think that I don't know if we already talked about this. Soil is renewable, but it's an inexhaustible renewable resource. It takes a very long time to renew. So we're going to look at soil and what it's made up of, and this is called, we break it up into what's called soil horizon. So it's vertical layers, I guess horizontal layers that go up and down, and these are called soil horizons, and the entire thing is called a soil profile. So there's 6 soil horizons listed here, and this entire picture would be a soil profile. So generally the degree of weathering and concentration of organic matter decrease as you move down the soil profile. So there's going to be less weathering and less living things as you move down into the dirt, which you probably could have predicted. And then there is a process called leaching. And so basically what leaching is as water moves down the soil profile, what happens is it rains, then there's water in there, and then the water's in the top horizons. It dissolves the materials that are in the top horizons and carries those materials down with them to the further deep horizons. It's kind of like coffee in a coffee filter, right? So the way coffee is made is it's inside a little thing that keeps the coffee inside but allows the water to go through. You pour hot water in, the hot water dissolves the coffee, and then the dissolved coffee particles are able to move through the filter, and then you have coffee at the end with the coffee grounds still kept there. So this process is called leaching, and it's how chemicals, nutrients, minerals can be transported downward. So there's 6 horizons, and we're going to talk about them, but there's only really 4 that you need to know. Okay, so the first one is the O horizon. It's on top. It stands for organic. It's the litter layer. So this is where the organic material falls and then decomposes. So this would be made up of leaves, dead animals, waste, all of those sorts of things. Then we have the A horizon, which is the topsoil. Okay, and so this is a mixture of inorganic mineral components. So it's going to be made up of the actual non-living soil things combined with humus mixed in from above. So as it moves down. And topsoil is the most nutritive part of soil for plants, and it's vital for agriculture. So we're going to talk a lot about topsoil and how we need to maintain the health of the topsoil. Now, topsoil is dark in color. It has a loose texture, which allows roots to move into it well, and it allows water to be held well. So that's why it's so nutritive for plants. Now, O and A hold the most organisms that give life to soil, or hold most of the organisms that give life to soil, and they're vital for agriculture. So we need to sustain the organic matter in O and A in order to have successful agriculture. Then we have the E horizon. This is one that we are not going to talk much about, but basically it's heavily leached, it loses minerals, and yeah, that's all you need to know. Then we have the B horizon, which is the subsoil. So the B horizon contains all the minerals that have been leached from above. And then we get into the C horizon, which is partially weathered parent material. So we're getting more and more solid and more like parent mineral as we go down. And then the R horizon is actually one that's not considered very much as a horizon, because it's considered part of the parent material and not part of the soil. But that would be the actual rock, or the sedimentary rock, or the bedrock, or the lava that is then forming the soil. So you can think of it as topsoil, which is the A horizon, subsoil, which is the B horizon, and C, or weathered parent material, which is the C horizon, in addition with the O horizon on top. So those are the ones that we're going to talk about. So these soil horizons depict an idealized soil, a general kind of one, but soils contain a big variety. So as we move through different biomes, we would see different characteristics of soil, which lead to the different characteristics in life in the biomes. Okay, so we're going to talk about the qualities of a soil, and that there's there's a bunch of different ways to classify soils. And like we said, soil characteristics are very different from area to area. So the first thing we can talk about is its color. A soil's color indicates its fertility. So black or dark brown soils, basically the darker soils, are really rich in organic matter. They have a lot of living things in them, and if they're a pale color, then it would mean low organic matter. Then we also talk about texture, which is the size of the particles in a soil. And so we have kind of three different kinds we can talk about. Clay particles are the smallest, and they're less than 0.002 millimeters in diameter. We also have sand, which is the biggest. You've seen sand with your own eyes. That's between 0.05 and 2 millimeters in diameter, and silt falls between the two. So this triangle right here allows you to see the composition of the different kinds and what kind of soil it will make. So clay up here has a very high clay percentage. And then loam is a word that we use to describe a soil with an even mixture of each particle. So all these loams are in the middle. They have an equal combination of clay, silt, and sand. Clay soils have few pore spaces and are sticky, making it difficult for air and water to pass through. So they do not grow plants well because it's hard for air and water to pass through. Sandy soils allow water to pass through too quickly because it's more porous, and so that requires frequent irrigation, so that's harder to maintain. Loam soils with medium-sized pores are considered the best for agriculture. They hold water well, and so that makes it the best to grow in. A third way to classify soils is by structure, which measures the clumpiness of the soil. So soil that is heavily clumped is considered compacted and cannot absorb water as well. So if it's really, really smushed together, it's going to be hard for water to get in there, as you might imagine. So ones with the intermediate clumpiness are the best soils for agriculture, because if it's not clumpy enough, then water won't stay, it'll run off. And lastly, we'll talk about the pH of soils. So I'm sure you would have guessed this knowing what you know about pH, but soils with intermediate pH are best for plants, right around 7, which is where the pH of water. Soil that's too acidic or too alkaline, meaning basic, may inhibit the absorption of nutrients, leading to plant death. So a really acidic soil would prevent a plant from getting what it needs through its roots, or also with a basic soil. So there's a bunch, like we said before, there's a bunch of differences across the globe in the soil composition. And this is going to affect the way that plants can grow there. So when we talked about biomes, about how tropical rainforests had low fertility or low fertile soils, and that, which seems counterintuitive, but the reason for that is because there's so much precipitation there, and with the warm temperatures, that the nutrients are quickly leached out of the O and A horizons and into the E horizon. So they don't stay long because it rains so much. So the nutrients that we need to grow plants are just not there in the tropical rainforests. But there are people who farm in these regions. They do what's called swidden agriculture, where they would cultivate a plot of land for a few years. They're going to grow on that plot of land for a few years, and then after a little while, they're going to move on to another another plot of land and allow the forest to regrow where they